the acceleration of a body at that particular instant of time, which can be calculated by the formula limit delta t tends to 0, delta v divided by delta t. The relative velocity of two objects, that is velocity of one body with respect to the another body, is nothing but the relative velocity. V is equal to u plus at is a formula which is known to us kinematic equation. We know V equals u plus a t1. Average speed is nothing but the ratio of total distance travelled by a body to the time taken. Hello everyone, welcome to session 5 of chapter 3, Motion in a Straight Line. Till previous session, we were discussing about the theory part of motion in a straight line, and in today's session, we are going to discuss about the numerical part. I am Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So before starting with the numerical problems, let us discuss about the formulae what we have studied in this chapter. And the first one is speed. So what is the formula for calculating speed? It is distance divided by time, or velocity, that is displacement divided by time, which is given by s by t, where s is the displacement and t is time. Next we have average speed. Average speed is nothing but the ratio of total distance travelled by a body to the time taken. So the average speed is given by total distance divided by total time. If S1, S2, S3 and so on are the distances travelled by a body, which is travelled to a distance by taking the time t1, t2, t3 and so on, then the total distance can be calculated by taking the sum of all the distances, and the total time can be calculated by taking the sum of all the time period or the time interval where the body travelled. Next we have instantaneous speed, that is nothing but the speed of a particle or an object at that particular instant of time, which can be calculated by the formula limit delta t tends to 0, which means when time period is very short, delta x divided by delta t or dx divided by dt. Next we have acceleration. Acceleration is nothing but rate of change of velocity, and we have derived the formula with the help of initial velocity and final velocity and the time, that is v minus u divided by t is the formula to calculate acceleration, where v is the final velocity and u is the initial velocity and t is the time taken by the body. Next we have instantaneous acceleration, which means the acceleration of a body at that particular instant of time, which can be calculated by the formula limit delta t tends to 0, delta v divided by delta t. Next, we have kinematic equations. So, few kinematic equations are V is equal to U plus AT. Kinematic equations are nothing but the relation between the kinematic variables such as velocity, acceleration and time period and etc. So, V is equal to U plus AT is also our equation which is relating all the kinematic variables. Next, S is equal to UT plus half AT square, where S is displacement, U is initial velocity, T is the time period and A is the acceleration. Next we have V square is equal to U square plus 2AS. So all these derivations we have derived with the help of VT graph, and equations of motion under gravity, that is this equation can be written as V is equal to U plus or minus G into T. For a freely falling body, G is conventionally the sign for the body which is falling under the gravity is taken as positive, and the body which is thrown upwards is taken as negative. So it can be written as V is equal to U plus or minus G into T, and S is equal to UT plus half GT square. V square is equal to U square plus 2GS. The same kinematic equations, but for the motion under gravity can be written as V is equal to U plus or minus GT, S is equal to UT plus half GT square, and V square is equal to U square plus 2GS. Next, the relative velocity of two objects, that is velocity of one body with respect to the another body, is nothing but the relative velocity. Relative velocity of A with respect to B is given by VAB is equal to VA minus VB, which we have studied in the previous session. Similarly, if you want to calculate the relative velocity of B with respect to A, then this formula is VBA is equal to VB minus VA. So, with this information, let us begin with the first numerical. So, it is saying that an automobile moves at 40 km per hour for 3 km and at 50 km per hour for the next 3 km. Find the average speed of the automobile. How to find the average speed? We have discussed about the formula just now. So let us see how to calculate. The velocity of an automobile, that is V1, is 40 km per hour initially, and for the next 3 km it travels with the velocity of 50 km per hour, and this distance is nothing but 3 km and 3 km, and it is taken as d1 and d2 respectively. We need to calculate the average speed. Students, it is very important to write or to note the given data before entering to solve the problem, because that will give us an idea what is the relevant formula that we can apply to find the answer. So here it is saying that first automobile is moving for 3 km with the velocity of 40 km per hour, and the next 3 km the automobile is traveling with 50 km per hour. So average speed can be calculated by the formula total distance divided by total time taken. Total distance is nothing but the sum of two distances, that is 3 km plus 3 km, that can be given by d1 and d2. So it is d1 plus d2 divided by the time taken to travel that distance, that is t1 plus t2. Now let us substitute all the values to calculate t1 and t2 values. So t1 is nothing but d1 divided by v1, because we have distance divided by time is equal to v. We want t, that is d divided by v. So like this we can apply for t1, that is d1 by v1 we get. So d1 is nothing but 3 km, and the velocity of the automobile initially is 40 km per hour. So it is nothing but 0.075 hours, because time is asked, and hence it is 0.075 hour. Similarly t2, that is d2 divided by v2. d2 is again 3 km. The velocity of the automobile for the next distance, that is 50 km per hour. So you will get time t2 is equal to 0.06 hour. And therefore average speed can be calculated as d1 plus d2, that is 3 plus 3, because we know d1 is 3 km and d2 is equal to 3 km. So 3 plus 3 will get 6, and t1 plus t2, t1 is 0.075 plus 0.06, we will get 0.135. So 6 divided by 0.135 gives us 44.44 km per hour. But the average speed is to be calculated, and the SI unit of speed is meter per second. So we need to convert this kilometer per hour into meter per second. So let us now convert this kilometer per hour into meter per second. We have 44.44 kilometer per hour. So we have to convert it into meter per second. So 44.4 into kilo means 1000, that is 10 power 3 divided by per hour. Per hour is given, so that is in hour 60 minutes, and in each minute we have 60 seconds. So 60 into 60, that will give us 12.34 meter per second. So the average speed of an automobile is calculated, that is 12.34 meter per second. Let us see one more problem. A ball thrown vertically upwards with a velocity of 20 meter per second. A ball is thrown vertically upwards with the velocity of 20 meter per second from a top of a building. Consider this diagram. This is the top of building. From here the ball is thrown vertically upwards with the speed of 20 meter per second. The height of the point where the ball thrown is 25 meter from the ground. So from the ground, the top of this building is at 25 meter, because this is where the ball will be thrown from this point. So from the ground, this point is about 25 meter. How high will the ball rise? How high the ball will go when it is thrown upwards, and how long it will be before it hits the ground? How long the ball will be in air before it hits the ground is the question. So in the question it is also given, take the acceleration due to gravity, that is g is equal to 10 meter per second square. This is a question which is asked in the final examination. So look at the diagram carefully. This is ground and this is the building. From the top of the building the ball is thrown upwards, and the question is how high the ball will reach and how long it will stay before it hits the ground. The top of the building is 25 meter from the ground. I hope the question is clear to all of you. Now let us look at how to get the solution for this question. Here, the total motion of the body is divided by two parts. How it is divided as two parts? From point A to B as upward motion. This is where the ball is thrown. From this point to this point, the ball is thrown upwards. After it reaches one point, it will fall down. So, it is divided into two parts. One is upward motion, the other one is downward motion. So, it is divided as A to B, that is upward motion, and from point B to C as downward motion. From here, after it reaches one point, it will come back to the ground. So, B to C is the another part, that is the downward motion. Therefore, upward motion, the initial velocity of the ball is 20 meter per second. It is given in the question clearly. So, U is equal to 20 meter per second and V value is 0 meter per second because there is no final velocity for it. Initially, the ball will move upwards with a velocity of 20 meter per second and hence U is equal to 20 meter per second. And acceleration due to gravity, that is conventionally it is taken as minus g because it is going against the gravitational force. So, minus g value is given in the question, that is 10 meter per second square. Here we have to consider minus 10 meter per second square since the ball is going upwards. And S is equal to y minus h. What is S? It is displacement. We need to calculate how high the ball will go. So, that is y minus h, because from ground to that point, the higher point, we have considered it as y, and here the top of the building to ground we have considered it as h. So, y minus h will give us the value of the height of the ball which is thrown from the top of the building. So, S is equal to y minus h is what we have to find out. That is our first task. So, formula we use to calculate this is v square is equal to u square plus 2as, because we know a value, we know u, we know v, but we have to find s. So, this formula is relevant to get the right answer. So, let us now substitute. We know the value of v is 0 and u is 20 meter per second. So, it is v square is equal to u square plus 2as. So, v is 0, u square is 20 square plus 2 into a is minus 10 and s is not known to us, that is y minus h. So, let us now simplify this. So, 0 as it is we have taken 20 square, 2 into minus 10 is minus 20 into y minus h. So, just rearrange the terms. 20 into y minus h, taking this to the other side, we will get 20 into y minus h, which is equal to 20 square. Y minus h is equal to 20 square divided by 20, and 20 square gives us 400 divided by 20, which is nothing but 20 meter. So, y minus h is nothing but the height of the ball which it reaches when it is thrown from the top of building. So, y minus h value is 20 meter, which means the ball will rise up to the height of 20 meter when it is thrown from the top of the building. We have calculated the first thing, that is how high the ball will rise. It will raise up to 20 meter. Now, the next thing what we have to find is how long it will be there in the air before it hits the ground. Let us now find it. So, let T1, we don't know what is the time that it will stay in the air before it hits the ground. So, we will take it as T1 be the time taken to travel y minus h. This is y minus h, that is when the ball is thrown upwards, the time taken for the ball to reach to the point B, that is time T1, and V is equal to u plus at is the formula which is known to us, kinematic equation. We know V equals u plus a T1. So, V is 0 and u value, that is initial velocity, is 20 and a value is minus 10, T1 we have. So, T1 is equal to 20 divided by 10, that is give us 2 seconds. Let T2 be the time taken to travel from B to C. So, this is B to C. We will consider T2 is the time taken to travel from B to C. Then for downward motion, u is equal to 0, a is equal to plus g 10 meter per second square. Why it is plus g? Because for a freely falling body, g is taken to be positive when it is traveling downwards. So, it is plus 10 meter per second square. So, s is equal to 25 plus 20, Why it is 25 plus 20? Because S is nothing but the displacement, because H is already given 25 and this distance is calculated, that is 20 meter. So 25 plus 20 gives us 45 meter. We have the formula to calculate displacement. S is equal to ut plus half gt square, and S is 45, u is 0, 0 into t will give us 0 only, half, g is 10, t square, t2, we have considered the time taken for the ball to reach back to the ground, so t2 square. So simplifying this, we will get 5 t2 square, which is equal to 45, because we have 45 here, 2 ones are 2 5s are, so 5 t2 square is equal to 45, t2 square is equal to 45 by 5, 5 ones are 5 9s are 45, and t2 is nothing but square root of 9, which is 3 seconds. The total time taken for the ball to reach the ground is given by t1 plus t2, because t1 to raise upwards and t2 to fall downwards. To reach the ground, the total time taken is t1 plus t2, that is 5 seconds. And therefore, the ball will be 5 seconds in air before it reaches the ground. So next question we have, a cyclist starting from rest, he covers 100 meter distance in 5 seconds. Assuming his acceleration is uniform, calculate his velocity at the end of 5 seconds. So here we have to assume that the acceleration of a cyclist is uniform and we need to calculate his velocity at the end of 5 seconds. So what is given? It is initial velocity is not given. Since it is not known, we can take u is equal to 0 and s is nothing but the distance covered by a cyclist, that is 100 meter, and time taken by him to cover this distance is 5 seconds. We need to find his velocity. So which formula fits all these data? That is s is equal to ut plus half at square. S is nothing but the distance, that is 100, which is equal to initial velocity is 0. So 0 into t is nothing but 0 again, half. A is not known to us, so A, and t is nothing but 5 seconds, so 5 square. So it is nothing but 5 into 5, 25A. 25A is equal to 100 into 2 is nothing but 200. Then A is equal to 200 by 25, which will give us 8 meter per second square. So we have to calculate velocity, which can be calculated by the formula v is equal to u plus at, where v is nothing but the final velocity. At the end of 5 seconds, we need to calculate velocity, which is nothing but the final velocity. V is equal to initial velocity is 0 and acceleration is 8. We have calculated 8 meter per second square. So acceleration is 8 and time is 5 seconds. It is given. So V is equal to 8 5s are 40 meter per second. So velocity is 40 meter per second at the end of 5 seconds. We'll see one more problem of similar type. A car moving along a straight road with the speed of 126 km per hour is brought to rest within a distance of 200 meter. What is the retardation assumed to be uniform, and we have to calculate the time taken for the car to stop. What is the time taken for the car to stop? Assuming the retardation is uniform. You know what is retardation? We have learned this in the theory class. So we know initial velocity is given for a car which is moving in a straight line or straight road, that is 126 km per hour. We need to write this in terms of meter per second since it is the standard unit. Let us convert this into a standard unit, that is meter per second. How to convert? 126 km per hour is given. So kilometer is nothing but 1000 meters. So 126 into 1000 divided by per hour, that is 3600 seconds, which means in our 60 minutes, each minute has 60 seconds. So 3600, so it will give you 35 meter per second. So kilometer per hour is successfully converted into meter per second. So we have to be very careful in the conversion. The final velocity is not given, so it is v is equal to 0 and the distance travelled by the car is 200 meter. So s is equal to 200 meter. Acceleration we have to find, that is the retardation, and also the time taken for the car to stop we have to find. So we have the formula v square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration and s is the displacement or the distance. So we have u value is 35 meter per second, that is 35 square, since it is u square here, and 2 as it is, a as it is, s is nothing but the distance travelled, so 200. So a is equal to, take this to other side, that is minus 35 square divided by 2 into 200 is 400, and the answer we'll get after simplification is minus 3.06 meter per second square. Since it is acceleration, the unit is meter per second square, you should not get confused. Now we have to find acceleration is calculated, that is minus 3.06 meter per second square. We have to find the time taken for the car to stop. So v is equal to u plus at. The formula we have, so v is the final velocity, the value is 0, u value is 35, as we have converted the 126 km per hour into meter per second, that is 35 meter per second, and plus at we have, acceleration value is minus 3.06, so here minus 3.06 into t. So we need to calculate t, just rearrange the terms, you will get, take this to the other side, you will get plus 35, and this 3.06 will come into the denominator. So you will get t is equal to 35 divided by 3.06, which is nothing but 11.76 seconds is the time which is required for the car to stop. These are some interesting numerical problems based on motion in a straight line concept. In the next session, we'll come up with few more examples. Until then, take care all of you. Thank you.